So this is the last question for chapter 12.5 for math 1325. So this one, they want to find the absolute maximum and minimum for these functions, and they give you two closed intervals. And I like to put something like this on the test, so make sure you know how to do it. So we're going to write down number 68. The function is 2x cubed minus 3x squared minus 12x plus 24. And we're looking for absolute max and means. They give you one of the interval is -3 to 4, and other interval is -2 and 1. All right. So I know this graph is going to be an odd leading power 3, right? With A is positive. The maximum turn is degree 3 minus 1 equal to 2. All right, so the end behavior should be odd leading a positive one side up, one side down, 2 turns, just a regular S curve, right? And we just want to keep that in mind. This is harder because they have the closed interval, so you cannot just say, okay, no maximum, no absolute max, no absolute mean, because they cut it into certain interval, right? So let's start with the first derivative. If I take the first derivative of this, we got 2 times 3 is 6x, 1 less degree is 2 minus 3 times 2 is 6 again, this time x to the first minus the 12, x is gone, 24 turned into 0, right? So that's the first derivative. And then we can find a critical number, right? So critical number is setting that equal to 0. 6x squared minus 6x minus 12 equal to 0. Look like I can divide everything by 6, right? Or you can pull out the 6 outside, either way. Pull the 6 out and we have x squared minus x minus 2 equal to 0. So hopefully you know how to factor pretty well now. If you factor that, what do we get? It's going to be x times x, and then 2 times 1. This one is bigger, so negative, but we can double check. X times x is x squared. Negative times 1 is -2. Outside we have plus x minus 2x is -x. So set each of them equal to 0. 6 doesn't equal to 0. X minus 2 equal to 0. X plus 1 equal to 0. X equal to 2. X equal to -1. So those are my critical number. So remember when it has the closed region, which we have -3 and 4, right? What you need to do is you need to test critical number along with the endpoint. So, which means plug it back to the original functions and plug in my critical number 2 and -1, and also my endpoint -3 and 4. And 2 and -1 are in here, right? So we have to use them. So take a minute, try to find me those numbers. You should be able to see the first one. Once you're done, is going to be 4. This is 31. This is -21 and 56. So I can see that this is the biggest one. This is the smallest one, right? So I'm going to say for the A part, with the endpoint -3 and 4, we have an absolute minimum -3, -21, and then we have an absolute maximum at 4 and 56. So I hope that makes sense. You can pause the video and write that down, and then I want you to try C on your own. And once you're done, then we can check your answer. So this time again, my critical number and endpoint, right? So my endpoint for C is -2 and 1. And my critical number was x equal to 2, x equal to -1, right? So x equal to -1 is in here, but x equal to 2 is outside there, right? So what I mean by that is my endpoint should be -2 and 1, right? And then I have my x equal to -1 would be, this is like 0, -1. -1 is here, right? But x equal to 2 is here. So 2 is not part of the restricted interval. So when I plug in those points, normally I should plug in 4 of them, right? My 2, -1, and then -2 and 1, right? But because 2 is not part of it, so we can get rid of that. And then f of -1 equal to 31. F of -2 is 20. F of 1 is 11. So look like this is the smaller one. This is the biggest one. So I'm going to say the absolute maximum is going to be -1, 31. The absolute minimum is going to be 1 and 11. So hope that makes sense. You may see some of the exam question kind of like this. All right. If you have questions, you can email me.